Lesson 3.3 on properties of logarithms. So we've got four properties here to go from a logarithm of a single term or multiple terms that are being multiplied, divided, raised to a power, and ways that we can transform those logarithms using properties. Sometimes it's more convenient for a logarithm to be expanded out as much as possible. Sometimes it's easier for it to be condensed. So we're going to use these properties both ways. So the product property says that the log base b of x times y is the same as log base b of x plus log base b of y. The quotient property says log base b of x divided by y is equal to log base b of x minus log base b of y. So division changes to subtraction. The power property, log base b of x to the p power, is the same as p times the log base b of x. So you can bring the exponent down in front of the logarithm. And then the change of base property is used so that you can find a logarithmic value in your calculator if your calculator does not have the change base function inside of it. So it's easier for me to type log of the bigger base divided by log of the smaller base in my calculator than to go to math and then down to the log base function. So let's look at some examples on how to use these properties. So first we're going to express each logarithm in terms of log 5 and log 3. So what we want to do is figure out how these numbers relate to 5 and 3 so I can rewrite them in a different way. Well, I know that 15 is the same as 5 times 3, so I could write log of 5 times 3, that's the same as 15. Then I can change the value, and since I know that multiplication changes to addition, I can write log of 5 plus the log of 3. Now we're not actually finding out what this value is, we're just rewriting these in other terms. Same thing for the log of 75. I know that I can get 75 from 25 times 3. So if I think of log of 25 times 3, then I can transform that again and say, well, I know that 25 is 5 squared times 3. So whatever is being multiplied, that's going to separate into two logs that are being added. So I can say log of 5 squared plus log of 3. Then any exponents will come down in front of that log, and I can write 2 log 5 plus log 3. Okay, log of 5.4 may be a little bit difficult. We're trying to figure out how I can write 5.4 in terms of a 5 and a 3. So one way that I can do it is I know that 27 divided by 5 is equal to 5.4, and that just kind of takes playing around in the calculator and using 5 and 3 in different ways. I know that 27 is 3 to the third power. So since division changes to subtraction, I can write this as log base 3 or log 3 to the third power minus log 5. And then my exponent comes down out front. So this is 3 times log 3 minus log 5. Now we're going to do the same thing on example 2. This time it's just natural logs, and we want to write in terms of 2 and 3. So part A, I have the natural log of 0.66 repeating. So I know that 0.66 repeating is the same as 2/3. So natural log of 2/3. And I know that division changes to subtraction, so I can write natural log of 2 minus the natural log of 3. So whatever we do, we're trying to rewrite it in terms of the log or natural log that they give us. Okay, natural log of 9 over 8. I know that 9 is the same as 3 squared, and 8 is 2 to the third power. So natural log of 3 squared divided by 2 to the third. I'll separate those with subtraction. So natural log of 3 squared minus natural log of 2 cubed. I'm going to bring my exponents down out front. So 2 natural log of 3 minus 3 natural log 2. Okay, part C, natural log of 54. So I'm going to do this time 2 times 3 cubed. I know that 3 cubed is 27, so 2 times 27 is 54. Then I can separate this into natural log of 2 plus natural log of 3 cubed. Then I bring my 3 down out front, so natural log of 2 plus 3 natural log 3. So we're just using those properties to rewrite in terms of other logs and natural logs. Now we're going to take these logarithms and expand them. So we're given a single logarithm. I want to expand it into as many logarithms as possible. So on part A, I have 3 terms that are being separated by multiplication. So that means I'm going to wind up with 3 logs in this problem. So I'm going to write log 12 plus log x to the 5th plus log y to the negative 2. Then I'm going to take my exponents and bring those down front. So log 12 plus 5 times log x minus 2 times log y. So I've expanded this as much as possible. There's nothing else I can do to that. Same thing for part B. I have 2 terms that are being divided, so division is going to change to subtraction. So I'm going to write the natural log of x squared minus the natural log of the square root of 4x plus 1. Now the square root of a term is the same as raising it to the 1/2 power. So I'm going to rewrite that as an exponent raised to the 1/2 power. Then I can bring my exponents down front, so 2 natural log x minus 1/2 natural log 4x plus 1. Okay, now in example 4, we're going to condense the logarithm. So I have multiple logarithms. I want to write it in terms of one logarithm. So first thing we're going to do is take any numbers that are in front of the log, and those become the exponents of those terms. So this will be log base 2 of x plus 1 raised to the negative 5 power plus log base x of 6x to the 3rd power Okay, now raising to the negative 5 power is the same as 1 over whatever that term is to the 5th power. So this is log base 2 of 1 over x plus 1 to the 5th. And since the second logarithm has 6x raised to the 3rd power, I'm going to go ahead and cube everything in parentheses. So that's going to be log base x of 216x cubed. Now I can't go any further on this one because my bases are different. I have log base 2 and log base x. Different bases I cannot combine into one logarithm. Okay, so part 4, we're going to take the numbers that are in front of the logarithm. Those become the exponents. So natural log of x minus 4 to the 6th plus natural log of x to the 3rd. Now since I have 2 logarithms that have the same base and are being added together, then I can change that to multiplication. And remember that natural logs are understood to be base e. So I can write this as natural log of x minus 4 to the 6th power times x to the 3rd. And it doesn't matter if you put the x to the 3rd in front of the parenthesis or behind. Multiplication doesn't matter the order. Okay, now we're going to use the change of base formula. So remember, this is optional. It just depends on if you want to use the log base function on your calculator or not. But log base 3 of 5 is the same as log 5 divided by log 3. So if I type that in my calculator, this is approximately 1.46. Same thing for part B. I can type log 6 divided by log 1/2. And this is approximately negative 2.58. So it's just another way to type in logarithms that are other than base 10. Okay, now we're going to look at a couple of word problems. So this one says that in photography, exposure is the amount of light allowed to strike a film. Exposure can be adjusted by the number of stops used to take a photograph. The change in the number of stops N needed is related to the change in exposure C by N equals log base 2 of C. And I want to know how many stops would a photographer use to get 1/4 exposure. So I'm going to plug in 1/4 for C. So N equals log base 2 of 1/4. And I'm going to use the change of base formula to type this in my calculator. So log of 1/4 divided by log 2. If I type that in my calculator, I get -2. So this means on my camera, I would have to change the f-stop to -2 in order to get the 1/4 exposure. Okay, last one says that diversity in a certain ecological environment containing two different species is modeled by this function. N1 and N2 are the numbers of each type of species found in a sample. So S equals N1 plus N2. Find the measure of diversity for environments that find 25 and 50 species in the sample. So we're just plugging into this formula. So D equals negative, and I'm going to put 25 over 75. 75 is 25 plus 50 times log base 2 of 25 over 75 plus 50 over 75 times log base 2, 50 over 75. Now, I would be very careful about trying to type this in at one time. I got errors every time I tried to type it in at once. So it was easier to type it into two different problems. And I did the 25 over 75 logarithm first, and then 50 over 75, and I got those answers. Then I was able to add those together and then change the sign because of the negative in front. So that was easier than trying to type it in at one time. So for this problem, I got that the diversity would be equal to 0.9183.